Hi, Shane! What are you doing?
I'm trying to understand molecular shapes in chemistry.
Well, let me take a look. Silly Shane, that's not how molecular shapes work.
How do they work, Ryan?
Well, they work by using the Vesper Theory, which is valence, electrons, shell...
I don't think that's right.
It's based on atoms!
Well, hi there!
Hello!
My name's Shane.
And I'm Ryan.
And we're here to teach you about molecular shapes in chemistry! Okay.
Now, what people normally think about shapes is these kinds of shapes right here. But that is wrong. You shouldn't be thinking about that. Instead, we should be thinking about shapes for the Vesper Theory.
The Vesper Theory is an acronym which stands for Valence Shell Electron Pair Repulsion Theory. And this was created by Ronald Gillespie. Good artwork!
Thank you! Warning. The next few minutes contain large amounts of education. You have been warned.
So, we are now on to how Lewis dot structures correlate with the Vesper Theory. So, what we have here in front of us is a Lewis dot structure of nitrogen trichloride, which, in its Vesper Theory mode, as a shape, would be a trigonal planar. Now,
Or what do they look like, Shane?
he wanted this, not me. They look like fidget spinners. There, you happy?
Yes.
Alright. So, we're going to get that out of the way, and we're going to go back to this. And so now you can see why. And the other shape that this one can also only go to is a trigonal pyramidal, which has to do with, which will deal with other compounds as well, not just nitrogen trichloride. The next one that we're going to is a Lewis dot structure of methane. Now, methane actually has a very interesting shape, and that one is called a tetrahedral. Now, a tetrahedral is actually probably the best example to explain how the Vesper Theory, the valence shell electron pair repulsion theory, actually works. What the actual theory is stated as is it is the repulsion between the sets of valence level electrons surrounding an atom cause these sets to be oriented as far apart as possible. So this is by far the best one to show that all of these atoms want to get as far away from each other. So all four hydrogens do not want to be near each other or near the carbon atom in the middle. So they will try to get as far away until they're comfortable where they can still share their electrons all together, but they are far enough where they don't actually interfere with each other. So that is probably the best example for how Vesper Theory in molecular shapes actually works. On to the next one.
The next one is H2O, or as we all commonly know it is, water. Water is a bent shape because of the oxygen in the middle and the two hydrogens. It also is the best example of the octet rule, which states that a chemical compound tends to form so that each atom, either by gaining or losing electrons, has an octet of 8 electrons in its s and p orbitals.
So you can see that clearly on this, as all 8 of the electrons in the valence shell of oxygen are all connected to, 4 of them are connected onto the hydrogens on the side. Now we go on to the last one that we are going to explain, which is ammonia. Now ammonia is kind of like the nitrogen trichloride, as this is actually the trigonal pyramidal, which is actually another great example, like the tetrahedral one, that shows how the Vesper Theory works, is they all want to be as far away as possible. So, yeah, that is molecular shapes and Vesper Theory. And also, don't forget about Vesper Theory. Vesper Theory is valence, shell, electron, pair, repulsion. Isn't that right?
Yeah.
Explain to them what the octet rule is.
The octet rule is... the octet rule is the rule that states that compounds want to lose, share, or gain electrons so that they have 8 valence electrons in their s and p orbitals.
That's right! High five, people! If you did, that's okay too. Now, on to the creators of this wonderful and terrible thing! Ronald Gillespie and Ronald Hylam, who were partners who both created the idea of the Vesper Theory.
They probably got together because both their names were Ronald. Like,
yeah.
That makes sense.
Nitrogen trichloride. Which one is it? Do 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 do. Alright, you took too long. It's trigonal planar.
This one.
Woo!
The flat one with 3 sides. Everything, it went everywhere.
Methane. This one is tetrahedral. Tetrahedral is also the best example to show how the repulsion works between atoms in their molecular shape.
Because they are literally the farthest that they can be apart.
The next one we have is H2O, or water!
It's a bent shape, not a linear one, because that would be wrong.
And wrong is bad.
You don't like bad.
No.
Don't be bad.
The final one that we have is ammonia, which also is a trigonal pyramidal, which is also another great example to show how the repulsion theory also works with this theory. There's a lot of theories. Anyways, thank you for watching.
We'll insert a climactic ending somewhere.
Well, hi there.
Hello.
My name's Shane.
My name is Ryan, and we're going to be talking about... This sucks already.
They're these shapes, but that's just the funny business. Okay. Well, hi there.
Hello.
My name's Shane.
And my name's Ryan.
And we're here to teach you about shapes in...
And my name's Ryan.
Well, hi there, everybody. I hope you had a good lesson.
Me too.
And then we're also going to go... The creator of this, Ronald Gillespie and Hylam.
We don't have the picture anymore. They took it away.
Why?
We got sued.
Oh. Anyways.
Hey Shane, what are you doing? That's not your mom.
I thought we were going to... Hi.
It's based on atoms. Jesus
I did not know you were gonna hit them that hard.
I didn't think they'd go everywhere.